All right, guys, so we're picking up where we left off yesterday. Sum and difference of angles. So we did the first one of these two here. Now we're looking at the second one. And again, with these sum and difference of two angles, where they don't directly give us the angle, the degree, or radian angle, we're really going to need to set these triangles up to be able to solve these here. Now, what they want us to solve for this here is cosine of u plus v, cosine of alpha plus beta. Now, according to the formula, cosine of u plus v is cosine of u times cosine of v minus sine of u times sine of v. So we get this here just from the formula. So if we can find cosine of u value, sine of u, v, I think you need a piece of paper.
No, sorry.
You're good.
I don't like to believe it just now.
You're good. Now, if we can find the value for each one of these four, all right, guys, let's focus up here. We can plug them in and simplify to find the answer. Now, they told us cosine of v is negative 3/5. And it also told us that sine of u is 12/13. So really, we have half of the values that we need to be able to solve this here. We're just missing cosine of u and sine of v. Now, to get those two values, we're going to set up the triangles. Now, for cosine of v, angle v is between pi over 2 and pi. 0, pi over 2, pi, and straight down is 3 pi over 2. So our angle V's triangle would be over here in the second quadrant. This is between pi over 2 and pi. And they told us that cosine, negative 3/5, adjacent over the hypotenuse. Since we're in the negative x-axis, that side of the triangle would be negative, or negative 3, and the hypotenuse is 5. The hypotenuse is never negative, but our opposite and adjacent side on these triangles can be positive or negative. Questions on this here so far? Now, we need to find the third side of this triangle, and it actually does work out to be 4 because this is a 3, 4, 5 right triangle. The other way we can get at that is from our Pythagorean, our a squared plus b squared is equal to c squared. All right, guys, focus up here. We can plug in our 3 and 5. Well, 3 squared is 9, 5 squared is 25. Minus 9 from both sides, telling us a squared is equal to 16. So our other side is positive or negative 4. Now for us here, since we're in the positive y-axis, it's going to be positive 4. And the reason this is helpful is we are now able to find sine of v, because sine is going to be opposite over the hypotenuse, which is 4/5. So we can plug that value in for sine. Now the last one we need to find is cosine of u. And for that we need to set up our triangle for angle u. Now angle u is going to be between 0 and 2 pi. It's in the first quadrant. Now sine is opposite over the hypotenuse. Positive 12, and our hypotenuse is positive 13. Now we just need to find the missing side. So we can do a squared plus 12 squared is equal to 13 squared. Now our 12 squared is going to be 144. 13 squared is 169. At this point here, we're going to subtract 144 from both sides, telling us that a squared is 25. Square root both sides, a is positive or negative 5. But since it is attached to the x-axis, the positive x-axis, it's going to be positive 5. Questions on how we set that triangle up? Now for angle U, we're looking for cosine of U. Cosine is adjacent, and the adjacent side to U is 5. Hypotenuse is 13. Questions on how we found these given values? Now at this point here, we just need to simplify the statements. And now we could type all this into the 30XS or the graphing calculator. It will calculate the whole thing here. But we had to get to this point for it to be able to calculate it. If we do this by hand, 13 times 5 is going to be 65. 5 times negative 3 is negative 15. So 5/13 times negative 3/5 is negative 15/65. Our 12/13 times 4/5 is going to be 48/65. Now, yes, negative 15/65 does have a common factor. 48/65 does have a common factor, but we're going to leave it at this point. We're going to go on and subtract. Negative 45 minus 48 is going to be negative 63/65. Now they do have a common factor of 3. So we have negative 21 over 15. Because there's 1 or 2, 1, no, 3, negative 63/65, I believe is the final. Yep, it doesn't reduce. Even though the first two do have common factors, they don't reduce. Negative 48 or 48 over 65 doesn't. But this here, it doesn't reduce. I don't know why I was trying to reduce it by 3, but that's it. Yeah. I don't know why I was thinking that it reduced to 21, because that would have been 63. 21/63. The next one would be 66, which is 22. Questions on this here? You feel good with this so far? Now, luckily, especially on the homework, they're going to give you a single setup for this here. So they're going to give you kind of like the same thing we had to start with. They'll give you the angles and the value, and then you're just taking those and finding cosine of u plus v, cosine of u minus v, sine, tangent, secant, or not secant, but you just have one setup and you're going to go about finding it all from there. Does that make sense? Okay. That probably messed your truck up. But I bet the deer was probably worse off.
It didn't even die. It just ran off.
It ran off.
It was like a big 10-point bug. I was like, hey, that's a big deer. And it started running. I was like, uh-oh. And I was trying to slow down, but it was too late.
Yeah.
His head left and right from the passenger side of my truck with the headlights. And then I looked back and it spun and ran off.
At least it's better than the other way around, that the deer hit you. Yeah. Because that's your truck, and they probably don't have headlight covers. Okay, so that's not bad. Yeah, because if it's just that piece, because you can buy that straight cover pop the old one off, pop the new one without having to pull that entire unit out. Should.
My light still works. I was surprised it still works.
Yep. Well, hopefully you get it fixed before all that rain comes. All right, guys. Let's focus in. Let's look at this here. Now this here, so if we look at this here, we have cosine of arctan of 1 plus arc cosine of x. We have arctangent of 1 plus arc cosine of x. And really what this is lining up with is cosine of u plus v. Cosine of u plus v. We have two things that are being added together. Tells us two things. One, that u, this angle, is equal to arc, spell this right, arc tangent of 1, and v is equal to arc cosine of x. Now, out of the two of these here, one of these is going to be nicer than the other, and that's the arctan of 1. Because our angle u equals arctangent of 1 is really just telling us that tangent of u is equal to 1. Tangent of u is equal to 1, or positive 1. And there's one place that tangent of u equals 1, and that's when our u, our angle, is pi over 4. And that's kind of nice to know because our pi over 4, especially with tangent, is going to be 1 or negative 1. If we have a radian value with denominator 4, it's going to be 1 or negative 1. So we have that there. The other one is telling us that cosine of our angle v, not x, v is equal to x. Well, we don't have something that works with that there because it's just x. It is a variable. We don't have that on the unit circle or ways to find it, unlike tangent of u equals 1. There's a nice value for it. There's a nice angle that works. So here, well, all right, guys, if we're not sure we haven't used variables, well, we default back to a triangle where our angle here is v. Cosine is what over what? Adjacent over the hypotenuse. Now the adjacent side is x. What would the hypotenuse be? What's the denominator? Well, there's not one written under x, is there? So it's understood to be 1. Yeah. If there's not a denominator, it's understood to be 1. Because x divided by 1 is just x. If they don't write a denominator, it's 1. Questions on this here? Now we need to find the third side of this triangle. Well, Pythagorean theorem, a squared plus b squared is equal to c squared. So we're saying x squared plus b squared is equal to 1. All right, up here. Now at this point here, we can subtract x squared from both sides, telling us that b squared is equal to 1 minus x squared. At this point here, we can square root both sides, telling us b is equal to the positive or negative case of 1 minus x squared. But for us here, we're just going to be taking the positive case. We're not going to be focused on the negative. So that gives us a triangle to work with here based off our angle V. Questions on this so far? Okay. Now again, we said we're trying to find what? Cosine of u plus v. Well, cosine of u plus v is cosine of u, cosine of v, minus sine of u, sine of v. So we're going to plug some stuff in. Now, cosine of u. We know what angle u is. Angle u is pi over 4. But we still don't have a specific angle for v, so we're going to still just call it cosine of v. Sine of u, we know what u is. Pi over 4. Because for our cosine of v, sine of v, we're going to have to be using that triangle.
Good job, Ben.
All right. So, focus in here. Sine of and cosine of pi over 4 is square root 2 over 2. Now we just need to figure out what cosine of v and sine of v are. Well, cosine of v is just x. Because one, they told us cosine of v is x. And we could also find it in the triangle adjacent over the hypotenuse. X over 1 would be x. Sine of v, opposite over the hypotenuse. Well, the opposite side is 1 minus x squared. The hypotenuse is 1. Getting us to this here. Really telling us that square root of 2 over 2x minus square root of 2 over 2 times 1 minus x squared is our answer. Or if we want to factor this common term out, that's our answer. Because there are other ways that we could write it, simplifying down, multiplying in through with the square roots, but really that's as nice as we can get this. Yep. Yeah. Textbook did it a little differently. I'll show you that here. Really what they did is they actually multiplied these together, which is really just saying that we have square root of 2 x over 2 minus the second one, because these are both the same radical, we can multiply through. So we'd have the square root. Well, 2 times 1 is 2 minus 2x squared, giving us x squared of 2 minus 2 squared of 2. These are the same thing, it's just one's written differently. They actually multiply through. I really think the one in blue looks simpler, looks a little bit nicer than the other one, but they are the exact same value. Questions on this here? We're ready for the next one. All right. Well, essentially we have the exact same thing, but we're looking at sine of u plus v instead of cosine of u plus v, which does change the formula a little bit. This is also telling us that u is equal to arc tangent of 1 just like before, u equals arctangent of 1, which is just telling us that tangent of u is equal to 1. And just like before, u is equal to pi over 4. Okay. Questions about tangent? Okay, we ready for the second part? Yes. So the second part is telling us that v is equal to arc cosine of x, which means that cosine of v, our angle, is equal to x, yes? Okay. Well, now we've already solved this, yes? Because we literally did this not 2 minutes ago. We've already showed how to get the other sides, yes? Now, I'm saying all this kind of, let's put a humorous spin to it. With mathematics, unlike anything else, literally a lot of other things, if we've proven something once already and it's been proven, tested, shown that it does work, this theory is true, it doesn't have to be proved ever again. It'd be nice if that worked in other areas. Well, since 3 of y'all are cheerleaders, it's pretty much, we did this routine perfectly. Here's the video. All you have to do is reference it. Because literally in future proofs that reference other proofs, all they have to do is see this person's work, and that's it. They don't have to redo it ever again. They don't have to reprove it, reshow it. They just see here, which is the same thing we can do here. Because, as long as I put that on the right side, because x, 1. We could just say, see the previous problem. This is our triangle. We did it just a minute ago. Does that make sense? Like, there's no reason to redo this because it's the exact same thing. And some of the problems, especially on the homework, it will have the same setup for all 4 or each of the different parts. So you only have to do it once and then just refer back to it each time. Now, sine of u plus v is sine of u cosine of v plus cosine of u sine of v. Sine of u, well, sine of 45, pi over 4. Cosine of u would be cosine of pi over 4. Sine of v. Now, just like before, sine of pi over 4, square root 2 over 2. Now, cosine of v, x, plus cosine of pi over 4, square root 2 over 2. Sine of v is our square root of 1 minus x squared. So we almost get the exact same answer, except instead of minus between the two terms, we have plus. And the way the textbook has it would be square root of 2x. I don't like putting x after. Plus the square root of 2 minus 2x squared all over 2. But both of these are the same answer. Questions on this here? I think y'all are starting to notice we can't get away from triangles with trig. Trig is all about triangles. Are you ready for the next one? All right. Use a different formula to prove the identity of this here. So, this is part of what we skipped because we didn't do chapter 2.2. I realized later I labeled all the 2.3 videos as chapter 2.2. But 2.2 is just proofs. Now, proof, when we do a proof, we're wanting to show that cosine of pi over 2 minus x is equal to sine of x. We're wanting to show that these two sides have equality, that they are the same. So we'll start off with the left-hand side. Cosine of pi over 2 minus x. Now from here, we can use our difference property, which tells us that cosine of pi over 2 times cosine of x plus sine of pi over 2 times sine of x. Because it's our u and v. U in this case is pi over 2, v is x. Cosine of u times cosine of v plus sine of u sine of v. Now, according to the unit circle, cosine of pi over 2 is 0. So we have 0 times cosine of x plus sine of pi over 2 is 1. Zero times cosine of x is 0, which leaves us with 1 times sine of x, or is that what we wanted to show that it was equal to? Well, yes, we wanted it to show that cosine of pi over 2 minus x is sine of x. So we did that, so it is true. Now the thing with proofs is we cannot add or subtract things from both sides. We have to get the left to be like the right or the right to be like the left, because we can't move anything across this equal sign in a proof. If we're trying to prove that they're equal, well, in order for us to be able to move something from one side of this equal sign to the other means that we're assuming that they are equal. But we can't assume that they're equal and use the properties of equality to show that they're equal. We're using what we're proving. We're assuming what we're proving, and it just doesn't work. So we got to get one side to be like the other. So since we were able to rewrite cosine of pi over 2 minus x as sine of x, which what it is equal to, we can say that they are equal. Yeah. Geometry. Yeah. It was very rudimentary. We didn't do any rigorous proofs. We did some small ones but nothing too intense.
I remember them doing it silent, and I was really scared that we took it in the
Proofs, for the most part, are just a logical, what we do anyways to show something's equal or show something's true, just step by step. No, it was during homecoming. Students spilled, I think it was soda. Yeah. I just need to take it home and actually clean it. I do not know. Miss McClendon got that as a gift for me. So, one, that needs to be cleaned because of the stain, and two, it just needs to be cleaned in general. I've run a vacuum across it, but that's about it. So, yeah. Yeah, it'd be interesting. The pressure washer might work. It also might remove the top layer because it's already starting to roll. Yeah, steamers. One carpet you do, I mean, it needs it, but you wouldn't want to see it. Or not just this one, just the whole building. One year they did the exit to the cafeteria. I think it was like 5 or 6 times, and the water kept turning up brown each time.
They just feel like a chase of colors.
Yeah, but
I went to go get that extension cord and he's being nasty. What? Did he pull up a chair?
what's for
trash.
the...
And then he was like, oh, I'm sorry, Dave. I was like, yeah, move.
All right, guys. Let's look at this one here. Cosine of theta minus 3 pi over 2. So we want to write it, express this trig function only in terms of theta. So we need to use our sum and difference formula first, because it'd be cosine of u, so cosine of theta, and then we'd have cosine of v, our second angle, 3 pi over 2. And then we'd have theta and 3 pi over 2. Now, 3 pi over 2. For cosine, it is 0. For sine, it is -1. So this first whole expression is going to become what? 0, so it's gone. The other side, we have sine of theta times -1, which gives us negative sine of theta. Questions on this here? We're going to do one last one, and then we are going to be done for today. Tangent of theta plus 3 pi. Now, all right, guys, focus in. Tangent of theta plus 3 pi, according to our theorem, so it's tangent of our first angle given to us, which is theta, plus tangent of our other angle over 1 minus tangent of theta times tangent of 3 pi. So we're using our formula to get this here with u and v. Well, now let's figure out what tangent of 3 pi is. Tangent of 3 pi is 0. So looking back at this here, well, that's going to be 0. That's going to be 0. So we really have 0 tangent of theta times 0. So really the numerator is just going to be tangent of theta. Well, this denominator, that part is gone, leaving us with just what? 1, which is just tangent of theta. That's it. Questions on this here? We'll go with this here. Yes? All right. Well,